Hello guys, and welcome back to the course. In today's lesson, we're going to carry on with the concept of improper integrals. But in this case, we want to compute the area under the curve of a function f of x in an interval a, b, where either a or b are infinite discontinuity for the function f of x. Now, we're going to divide this particular case of improper integrals in three other cases. The first one is when we have the integral from a to b of f of x dx, and a represents an infinite discontinuity. The other case is when b represents an infinite discontinuity. And the last case is when there's a point C between a and b where c is an infinite discontinuity. In this last integral, we need to split it in two. We need to compute the integral from a to c of f of x dx plus the integral from c to b of f of x dx. In all of the previous cases, we are going to take a limit, but the question is, what kind of limit are we going to take? Well, for the first case, we're going to take the limit when t goes to b from the left. And for the second case, we're going to take the limit when t goes to a from the right. Let us compute the area under the curve of the function 1 over the square root of 9 minus x squared in the interval from 0 to 3. As we can notice, 3 represents an infinite discontinuity for this function. But either way, we can compute the improper integral. And in this case, we have the integral from 0 to 3 of dx over the square root of 9 minus x squared. But as we know that 3 represents an infinite discontinuity, we're going to take the limit when t goes to 3 from the left of the integral from 0 to t of dx over the square root of 9 minus x squared. Now, the solution for this integral is arcsine of x divided by 3, which we have to evaluate from 0 to t. If we do so, we will have arcsine of t divided by 3 minus arcsine of 0. But remember that we need to take the limit when t goes to 3 from the left. Now, arcsine of 0 is 0. And if we substitute 3 in the function, we get arcsine of 1, which is equal to pi over 2. Therefore, the area under the curve of the function 1 over the square root of 9 minus x squared in the interval from 0 to 3 is equal to pi over 2. Now, let us try to compute the area enclosed by the vertical lines x equal 2, x equal 5, and the function f of x equal 1 over the square root of x minus 2. For computing this area, we need to do the integral from 2 to 5 of dx over the square root of x minus 2. But 2 represents an infinite discontinuity, so we need to do the improper integral, meaning that we need to take the limit when t goes to 2 from the right of the integral from t to 5 of dx over the square root of x minus 2. We can solve this integral by applying substitution. U equals x minus 2 and the u equals the x, which results into 2 square root of x minus 2, which we need to evaluate from t to 5. If we do so, and then we take the limit when t goes to 2 from the right, our result for this area will be 2 square root of 3. For computing the area under the curve of f from A to B where there's a value C, which is an infinite discontinuity, we will do the improper integral from A to C of f of x dx plus the improper integral from C to B of f of x dx. For the first improper integral, we have to take the limit when t goes to C from the left, and for the second improper integral, we need to take the limit when t goes to C from the right. If both limits are finite, then we say that the improper integral converges. If not, we say that it diverges. That's it for today, guys. I challenge you to solve the following improper integrals. Remember that in this case, you need to take the limit when t goes to the value which represents an infinite discontinuity. And well, guys, see you in the next lesson.